Welcome back. We just stepped through a type 2 problem, so this is a level 2 difficulty. We had our first problem where everything worked out nice and smooth. We had one radical, we isolated it, we solved our equation, and we checked. In this particular problem, we had two radicals, so we had to isolate one, get rid of that radical, isolate another radical, get rid of that radical, and we ended up solving. But our final step of solving was really easy. Now we're going to look at another problem that's not quite as straightforward. So in this problem, we are going to look at the square root of x plus 1 is equal to 2 plus the square root of 2x plus 1. We're going to go through our steps in the same process that we have been, but they get a little bit trickier. All right, so step 1, isolate. I have one of my radicals isolated, so I'm going to be able to move on to step 2 at this point. So there's step 1. Step 2 is I'm going to raise each side of the equation to whatever's necessary to get rid of my isolated radical. So that means I'm going to square both sides. So when I square the left-hand side, I get the square root of x plus 1 times the square root of x plus 1, which is just x plus 1. And when I square the right-hand side, I have to remember to FOIL. First, outside, inside, last. All right, so I'm not going to write this out. I know that I've got the same thing repeated. So my first term is 2 times 2, or 4. My outside term is 2 times the square root of 2x plus 1. My inside term is 2 times the square root of 2x plus 1. And my last term is this plus the square root of 2x plus 1 squared. All right, simplifying. Okay, so now I have x plus 1 over here is equal to 4. These two terms are the same index, the same radicand. So this becomes plus 4 times the square root of 2x plus 1. This just becomes plus 2x plus 1. So this is x plus 1 is equal to 5 plus 2x plus 4 times the square root of 2x plus 1. I'm going to bring this 5 plus 2x to the other side. So that will give me negative x minus 4 is equal to 4 times the square root of 2x plus 1. I'm going to divide both sides by 4. And I'm going to divide both sides by 4 and pull a negative 1 out of this left-hand side. So that's going to give me negative 1/4 times x plus 4 is equal to the square root of 2x plus 1. If I took this negative and distributed it back in and multiplied both sides by 4, I would get back to this point here. This is just a little nicer for my next step, which is going to be step 2 again, where I'm raising each side to a power because I've now isolated my variable, or I'm sorry, I've isolated my radical. So now when I square this left-hand side, I have two factors. So this is going to be negative 1/4 squared times x plus 4 squared is equal to the square root of 2x plus 1 squared, which is just 2x plus 1. Negative 1/4 squared is going to be 1 over 16. And when I square this, I'm going to need to FOIL. So that's going to be x squared plus 8x plus 16. You can step through the foiling on your own if you'd like. You can pause the video and check that. Equals 2x plus 1. I don't like this 16, so I'm going to multiply both sides by 16 just to kind of get rid of it, and I don't like working with fractions. So now I have x squared plus 8x plus 16 is equal to 32x plus 16. I'm going to bring everything over to the left-hand side by subtracting 32x and 16. So that's going to give me x squared minus 24x is equal to 0. At any point, if you don't trust my math, make sure you pause the video and check on your own. This factors to be x times x minus 24. I see a greatest common factor. I'm now at this solve step. So now I'm solving. I have a quadratic, but in this case, there's no third term. So I'm going to solve by factoring. And when I solve by factoring, I just factor out the greatest common factor of x, so I get x is equal to 0 or x is equal to 24. Both of those will make a true statement there. I need to go back through and check both of these in my original equation. So I'm going to do that check over here. So when I check x equals 0, I get the square root of 0 plus 1 is equal to 2 plus the square root 2 times 0 plus 1. Well, the square root of 1 is equal to 2 plus the square root of 1. 1 is equal to 2 plus 1. 1 is equal to 3. This is not true. So x equals 0 is not a solution. It's extraneous. When I check the solution x is equal to 24, I get the square root of 24 plus 1 is equal to 2 plus the square root of 24 times 2, which is 48, plus 1. So that's the square root of 25 is equal to 2 plus the square root of 49. Square root of 25 is 5. 2 plus the square root of 49 is 7. 5 is equal to 9. Again, this is not true, so 24 is also an extraneous solution. This problem also ends up with a no solution. It's not always the case that you'll end up with no solution in these types of problems, but you will sometimes end up with one answer that works, one answer that doesn't. Maybe both answers work, maybe neither answer works. But it's really, really important that we go back through this step and check. This doesn't mean that I made mathematical errors over here. Every time we square our problem, we are eliminating signs, which means we're making things positive when they might actually be negative. So we need to make sure that we go back and check to make sure that squaring things didn't cause any problem.